Welcome to the Deep Dive. We're the show that cuts through all the noise, digs into the sources, and basically gives you what you need to know fast. Today, we are really getting into n8n. It's this pretty powerful low-code platform, and it's honestly becoming a bit of a game changer for building some really sophisticated AI automation workflows. Our mission really is to unpack what makes n8n different, how it works as this sort of crucial middleware for AI, for large language models, LLMs, and most importantly, how you as a developer can actually use it. We're talking building robust, scalable, secure AI agents, the kind that can automate tricky tasks, remember past conversations, even answer questions using your own private data.
Yeah, and what's really interesting, I think, is how n8n fits in this unique space. It's not quite pure code, but it's definitely not just no code either. It's this hybrid. And it's getting a lot of traction, in the AI dev community, mostly because it handles so much of the background stuff, the boilerplate infrastructure that usually slows AI projects way down. Plus, and this is key, it's source available, the code's out there to see, which gives you this blend of open access, but still enterprise level control. And you can self-host it, often using Docker. That means organizations get total command over their data, their privacy, compliance, all that. It's a big deal against getting locked into vendors. Gives power back to the user.
That sounds really significant. So for someone maybe feeling a bit swamped by all the automation tools out there,
Yeah.
What is n8n fundamentally, and why pick it? Especially that hybrid thing you mentioned.
Well, at its heart, n8n is a workflow automation tool. It's built on Node.js. And the main idea is you visually build automations by connecting these things called nodes. Think of each node as one step in a process. It could be starting something, calling an API, changing data, talking to another app.
Okay, so it's visual, but you keep saying low code. What does that actually mean for a developer day to day? What could you do in n8n that you just couldn't in a pure no-code tool?
Exactly. That's the core difference. It's got that mix, the speed of visual building, but the power of code when you need it. That's kind of n8n's superpower. See, unlike those really restrictive no-code platforms, n8n gives you escape hatches. You can inject your own custom JavaScript or Python right into a node if you need complex logic. You can add NPM libraries, even just paste in a CRL request directly. So developers can sketch things out visually super fast, but then dive into actual code for the specific bits that make their app unique. It connects rapid prototyping with, real-world needs.
Right, okay. That makes a lot of sense. It avoids hitting that wall you sometimes get with no code where you just can't do that one specific thing you need. So let's shift to AI then. Especially with LLMs exploding everywhere,
Yeah.
how does n8n fit into that picture? How's it helping developers bring AI into their apps?
It really acts as the middleware. It's the glue connecting AI to, well, everything else. It takes care of all that boring but necessary infrastructure code, things like integrating with different APIs, setting up schedules, handling errors properly. And that's huge because it lets developers focus on the actual AI logic, the cool stuff. They can visually map out these multi-step AI agents without getting lost in the plumbing. It's about putting effort where it counts on the unique business problem.
And it's not just a couple of connections, is it? The ecosystem sounds massive. You mentioned, over 500 app integrations and more than 1,200 community templates that LLMs can just plug into via n8n.
It's absolutely huge, yeah. And growing all the time. That really puts n8n in the sweet spot. It's faster and more visual than trying to code everything with frameworks like, say, LangChain. But it's way more flexible and powerful than those purely visual drag-and-drop only platforms. So development teams can move much faster. They can focus their energy on the actual problem they're solving, not on rebuilding common connections or basic infrastructure, what we sometimes call, commodity engineering.
Okay, that ecosystem is definitely a big plus. Maybe the best way to really get it is to walk through an example. Let's say we want to build an AI workflow that processes content. What are the basic n8n building blocks we'd need to know?
Okay, sure. So first, you've got the workflow. That's your main canvas, right? Where you connect all the nodes together. Every workflow has to start with a trigger node. That's what kicks it off. It could be manual, like clicking a button. Or it could be on a schedule, say check every hour. Or driven by an event, like a webhook call. For content processing, yeah, a schedule trigger pulling an RSS feed is super common. Then data moves between these nodes, usually as JSON, and you use n8n's expression editor to grab pieces of that data, something like HTML.json.snippet that lets you pull out specific info dynamically. And really important for security, you handle things like API keys using n8n's built-in credentials management. It's encrypted. You absolutely don't want to hard code secrets.
Right, right. No hard coding secrets. So mapping that out, a typical content flow might look like schedule trigger starts it, then maybe an HTTP request node fetches the RSS data. You send that data to an OpenAI chat model node, ask it to summarize or pull out keywords, and you tell it to give you back structured JSON, right?
Yes, structured output is key.
Then maybe a set node to clean up or organize that JSON. And finally, push it into, say, a Postgres database using a Postgres node. Does that sound about right?
That's a perfect example, a really standard, useful pipeline. And here's something that makes building this in n8n feel quite different. The feedback loop is incredibly tight. If you were scripting this, you'd be adding print statements, running the whole thing, debugging. It's slow. In n8n, you can just click execute step on one node, like that OpenAI node, and see its output instantly. This means you can tweak your prompts, test your logic, iterate really, really fast. Plus, the workflow itself, the visual layout, it kind of becomes its own documentation. Makes it much easier for teams to understand what's going on.
Yeah, that instant feedback, that's not just a nice to have. It feels like it fundamentally changes how quickly you can build and refine these things. You go from idea to working prototype much faster.
Yeah.
Okay, so we've got a basic workflow. But how do we level up? How do we build something actually intelligent? An AI agent that can make choices, use tools, maybe even remember the conversation.
Okay, yeah, this is where it gets really interesting. The core piece here is the AI agent node. Think of it as the brain, or the conductor. It manages the user's input, talks to the LLM to figure out what to do, and decides which tools to use. Now, a tool in n8n isn't just some function. It's usually a whole separate workflow designed for a specific task. This encourages a really nice modular setup. For instance, you could build a web scraper tool as its own workflow. The main agent can then call on that tool when needed. And for conversations, you need memory. You connect memory nodes like window buffer memory or simple memory. These store the chat history so the agent knows the context. And absolutely crucial are the system prompts. This is where you tell the agent who it is, what its goal is, and exactly how and when it should use its available tools.
That modular tool idea sounds really smart, keeps things clean. So let's take that web scraper example. How would that work in practice? You'd have two workflows.
Exactly. Two workflows talking to each other. First, you build the tool itself, the web scraper tool workflow. It would probably start with a webhook trigger because the main agent will call it like an API. Inside that workflow, you'd have an HTTP request node to grab the HTML from a URL, maybe some nodes to parse the content you want, and then a respond to webhook node to send the results back. Then your main agent workflow. That might start with a chat trigger for the user interaction. It connects to the AI agent node, which in turn connects to your LLM, like OpenAI, and also to a memory node, maybe simple memory. The key step is configuring that AI agent node so it knows about the web scraper tool workflow and can actually execute it.
And how does it know when to use it? Is that purely based on the system prompt you give it?
Precisely. You explicitly link the tool scrape website workflow within the AI agent node's settings. Then, in the agent's system message, you write clear instructions, something like, you are an expert research assistant. If a user gives you a URL, you must use the website scraper tool to fetch and summarize the page. This points to an important concept. n8n is great for building these orchestrated agent-like systems. The agent isn't one big thinking thing. It's more of an architectural pattern. It's composed of these specialized connected workflows, which means each tool should be small, focused, testable on its own. That makes the whole system much more robust and easier to manage.
Okay, orchestrated intelligence. I like that. Now, speaking of complex agents and accessing specific knowledge, we absolutely have to talk about RAG, Retrieval-Augmented Generation. It feels like the pattern right now for getting LLMs to use private data, right? And hopefully stop them from just making things up, hallucinating. How does n8n handle our RAG?
RAG is huge, yeah, and n8n has really good support for it. Fundamentally, RAG is a two-step dance. First, you need somewhere to store your knowledge, typically a vector database. Think Qdrant, Pinecone, those kinds of things. They're built for searching based on semantic meaning, not just keywords. The data in there is stored as embeddings, which are basically numerical representations of your text or even images now. LLMs create these embeddings. You might use an embeddings OpenAI node in n8n. Similar concepts end up having numerically similar vectors. So the RAG process first is retrieval. You take the user's question, turn that into an embedding, and search the vector database for the most similar or relevant chunks of your private data. Second is generation. You take those retrieved chunks, give them to the LLM along with the original question, and say, okay, now answer the question using this context. The LLM generates an informed answer based on the provided information.
Got it. Retrieve, then generate. So if I wanted to build, say, a chat with your code base agent using RE and n8n, I'd probably need two separate workflows again. One to load the code knowledge in and another for the actual chat part.
That's exactly right. It's a very common and effective way to structure it. You'd have your knowledge ingestion workflow, maybe starts manually, uses a node like the GitHub document loader to grab your code files, then something like a recursive character text splitter to break the code into smaller, sensible chunks. Those chunks go to an embeddings node, maybe OpenAI's, to get turned into vectors. And finally, a qdrant vector store node configured to insert documents into your database. That's workflow 1 filling the knowledge base. Then workflow 2 is the RAG chat agent. Starts with a chat trigger, connects to the AI agent node. This agent would have access to a specific tool, often called something like a vector store question answer tool. This tool bundles the RAG logic. It connects to your qdrant node, but this time in retrieve documents mode. Plus, you need your LLM and memory nodes in there too. The cool part is the AI agent decides automatically, based on the user's question and its system prompt, whether it needs to use that RAG tool to fetch information before answering. This structure really turns n8n into a platform for building pretty sophisticated AI systems that are grounded in your specific data.
Okay, building these things is one challenge. But then there's production, making them reliable, scalable, secure, easy to maintain, the whole SRE and DevOps side of things. I heard this, frankly, terrifying stat somewhere that like 97% of workflows built in testing environments fail when they hit production. 97%.
That's rough.
It's a stark reminder, isn't it? Building the cool thing is often the easier part. Making it work reliably is where the real engineering comes in. We've all felt that production fire drill panic. So for resilience, number 1 is a centralized error workflow. You build a dedicated workflow just for handling errors. It gets triggered by a special error trigger node. And you configure this globally in settings, so all your production workflows use it if they fail. This error handler needs to do 2 things well. Comprehensive logging, push error details to a database, maybe Google Sheets, ideally a proper logging platform like Datadog or Logtail, and actionable alerting, send a message to Slack or email. Critically, with a direct link back to the failed execution log in n8n so you can debug instantly. Then, within your actual workflows, you use node-level error handling. Things like built-in retry mechanisms for network hiccups configure retry on fail on nodes, use try-catch blocks around critical steps, especially calls to external APIs like LLMs. And sometimes you want things to fail intentionally, so you stop and error nodes for business logic failures or failed validation checks. Now, for scalability and cost, if you're expecting any significant load, you have to run n8n in queue mode. This uses worker processes. It allows you to scale horizontally, usually using Docker containers managed by something like Kubernetes. That's essential for handling lots of simultaneous executions. Optimizing the workflows themselves is also key. Think batch processing where possible. Only fetch the data you absolutely need from APIs. And strongly prefer event-driven triggers like webhooks over schedule-based polling, which can be really inefficient. For AI cost optimization, which can get out of hand fast, you need visibility. Log your token usage and the estimated cost of every AI API call, maybe to a database so you can analyze it. You can also integrate with AI gateways like PortK or LiteLM. You just configure your OpenAI node's base URL to point to the gateway. Gateways give you centralized tracking, caching to save on repeat calls, rate limiting, super useful for cost control, and obviously make sure expensive AI workflows only run when truly needed. Security basics, run n8n itself as an unprivileged user. Always use HTTPS, usually via a reverse proxy like Nginx or Caddy. And I can't stress this enough. Always use n8n's built-in encrypted credential management. No secrets in the workflow itself. Ever. If you have webhooks exposed to the internet, secure them. Use header authentication at minimum, so only trusted sources can trigger them. And then there's general hardening. Disable features you don't use, like maybe the execute command node if you don't need it. Implement role-based access control, RBAC, if you have multiple users. Turn on two-factor authentication, 2FA. And be cautious with community nodes. Audit them before using them in production if you can. Lastly, collaboration and version control. If you have n8n Enterprise, it has native Git integration. That's ideal. Connect to GitHub or GitLab, use branches for dev, staging, prod, standard stuff. If you're on the community version, you need a disciplined manual process. Use strict naming conventions for workflows, like including version numbers. Always export the current workflow JSON as a backup before you start editing. Commit that JSON file to a Git repository with clear descriptive messages. Restoring means copying the JSON back into n8n. And absolutely run separate n8n instances for different environments, dev, staging, prod. Docker containers great for this. Use environment variables to manage configuration differences, like API keys or database connections between these instances. Don't hard code environment specifics. Essentially, you treat your low code RANA workflows with the same operational rigor as high code applications. Use DevOps tools like Terraform, Kubernetes, Prometheus, Grafana around it.
Wow, okay, that's a really solid playbook for taking any non project seriously from build to production. So let's try and tie all that together. Imagine a complex, production-ready capstone project. Something like an AI agent that detects anomalies in image data sets. Like, you feed it pictures of crops, and it flags the one picture of tomato because it doesn't belong with the corn and wheat images. How could n8n orchestrate something like that, applying all those production principles?
Okay, yeah, that's a great example. It definitely requires a multi-workforce setup, hitting a lot of the points we discussed. You'd likely start with an ingestion pipeline, maybe a manual trigger, or it watches a cloud storage bucket. It fetches the image data set, say from Google Cloud Storage, then critically it uses a multimodal embedding model. Not just text anymore, maybe calling out to Voyage AI or a similar service via an HTTP request node to get vectors representing the images. Those image embeddings, along with metadata, get uploaded to your vector database, probably Qdrant again, using a payload index for faster searching later. That builds your baseline knowledge of normal crops. Then you might have a separate analysis and tooling pipeline. This could run periodically, maybe triggered manually first. It queries Qdrant to do some pre-computation, like calculating the center point of your normal crop clusters in the embedding space, and maybe figuring out appropriate distance thresholds for what counts as an anomaly. Doing this upfront helps the actual detection be faster. The real tool for the agent is the anomaly detection API workflow. This would start with the secure webhook trigger, because other systems, or a UI will call it. When it receives an input image URL, it first gets the embedding for that image. Then it queries Qdrant again, asking how far is this new image embedding from the known normal cluster center, NFF. An F node then compares that distance to the precomputed threshold. Based on the comparison, it sends back a JSON response via a respond to webhook node saying anomaly true or anomaly false. And finally, you could have an orchestrator and user interface workflow, maybe starting with an n8n form trigger, giving you a super simple web page to upload an image. That workflow then uses an execute workflow node to call your anomaly detection API tool workflow, gets the result back, and displays it to the user on the form page.
And that whole setup, that capstone, it directly uses a production playbook, right? You'd have centralized error handling for all those workflows. We try logic on the HTTP calls. You'd run it all in queue mode, probably on Kubernetes for scalability. The API webhook would need header authentication for security, credentials stored safely, and all those workflow JSON files would be versioned in Git. It really brings it all together. It shows n8n isn't just for simple tasks. So after that, what does this mean for you listening? We've kind of gone on a journey here, haven't we? From understanding n8n's place, that low-code, high-code mix, to building these quite complex AI agents using tools, memory, RAG, and then crucially thinking about how to deploy them properly with that production mindset. I think the big practical takeaway is that n8n really does let developers build serious data-driven AI systems much, much faster than traditional coding alone might allow. You can solve real business problems with this stuff.
Yeah, absolutely. And if you zoom out a bit, look at the bigger picture, n8n kind of shows us where complex AI development might be heading. It's maybe less about writing every single line of code yourself and more about being a smart orchestrator, intelligently connecting these powerful pre-built or custom-built components. It really helps bridge that gap between getting a cool idea working quickly and actually having a robust production-ready system. So maybe the question to leave you with is this. Think about your own work, your own organization. What process exists today that's complex, maybe manual, maybe frustrating, that could potentially be transformed? Could it become a sophisticated automated AI agent using this kind of orchestrated approach? Where are those bottlenecks that intelligent automation could just dissolve?
That is a great question. Definitely something to chew on. We hope you found some inspiration here to maybe explore these ideas in your own projects or just out of curiosity. Thanks for diving deep with us today.